So let's have a recap of the week so far. Polynomials. We've been doing things with them. We've added and subtracted. We've multiplied. Adding, subtracting, multiplication. There's only one thing left, and that's division. Division of polynomials can go one of two ways. It can go the easy way and the annoying way. I won't even say the hard way. The annoying way is following a very particular algorithm, just like long division is an algorithm. It's a process that you go through, and nobody likes doing it, but you grin and bear it. We are going to look at the easier side of polynomial division first, and then next week you can get into the more long and painful version of polynomial division. If I remember correctly, tomorrow will be First Friday, which means you guys have half a day, I think, so there won't be really a reason to try to get deeply into any more content, so there will just be kind of a review sheet for you to make sure you're practicing the things that we've been seeing this week. The numbers that I have on the screen are not polynomials. Well, technically they are. They're just a polynomial with one term that happens to be a constant. If you had to divide 153 by 17 and your calculator was out of batteries, right, there'd be a couple of ways you could do it. One way would be to break out long division, okay? But there is a slicker way to do it, and that would be, you'd have to recognize this, but, you know, maybe you can trust me, or you could say, yeah, eventually I'd get there. 153 is actually 17 times 9. So if we are doing 153 divided by 17, we are doing 17 times 9 over 17. And then look what happens to that common factor of 17. Boom, this shrinks down to 9. Okay, the same thing can happen with polynomials. You have one bigger polynomial being divided by a smaller polynomial, and maybe you'll get lucky and that smaller polynomial you're dividing by is one of the factors of the bigger polynomial, in which case you can just do some cancellation to get the result. So that's what we're going to start with, just to get used to handling this polynomial division. So it's the polynomial version of this, taking one polynomial and writing out its factors and then using that to your advantage during the division. So I'm going to switch over to a polynomial problem, show you 4 examples, and then tell you where to go from there. Sorry, that sounded bad. Tell you what to practice from there. Okay, so here is the first example of polynomial division. And remember, we are in the zone where we are going to guess that we're being asked to divide by something which is a factor of the larger polynomial. So in this case, we're being asked to take the polynomial x squared plus 4x minus 21 and divide it by x minus 3. And remember, division is just undoing a multiplication. So what we're after is what other little polynomial is there that if we multiplied it by x minus 3, we would get x squared plus 4x minus 21. So here we're going to hope that x minus 3 is a factor of x squared plus 4x minus 21, because then we can cancel the factors like in that numerical example that I just did. In other words, this, you know, we're not ready to finish this yet, but we're going to hope that the numerator is factorable into something times x minus 3 over x minus 3, and in that case the x minus 3's will cancel. And there go the dogs again. Okay, we might be in the clear from barking dogs. So what I'm going to do is set aside a little mini problem, and I'm going to find out, can I factor x squared plus 4x minus 21 into, you know, the open question could just be, how does it factor? We're going to hope that one of the factors is x minus 3. So I'm going to go ahead and load that up. Just crossing my fingers, right? So our job is to figure out the polynomial that'll go there that will produce x squared plus 4x minus 21. So first of all, notice that since the leading term over there, the x squared, is going to be this x times the leading term of this one, this can only be an x. It can't be a 2x or a negative x or anything, because then we wouldn't lead off the product on the left with an x squared. Then the other thing we have to do is come up with the magic number to put in that second spot that would give us a product of negative 21 from the original on the left, and also manage to allow us to create the positive 4x in the middle. So with my negative 3 already sitting in place, if I need a number that goes to multiply negative 3 to produce this negative 21, that number needs to be plus 7. And then does this magically produce the 4x in the middle if we go back and forth? Well, if we take the thing on the right and multiply it out, we would get x squared from the first terms, then we'd get a minus 3x from the outer terms, a plus 7x from the middle terms, and a minus 21. And sure enough, that's x squared plus 4x minus 21. Okay, so the numerator of our quotient does indeed factor to x plus 7 times x minus 3. So I'm going to fill in that x plus 7 up at the top now. And I've pre-canceled my x minus 3's because I was hoping for the best, and that actually works. So the net result of that division is, the result is x plus 7. Again, just like that 130 or 50 whatever divided by 9 ended up being 17 in the numerical example I did. Okay, so successful completion of these preliminary, simplified for your protection division problems of polynomials is going to rely on your ability to factor. That may be good news, it may be bad news, but it is what it is. The worksheets will present you these division problems in this format, so not written as a ratio yet, but with just the good old division symbol in the middle. I don't like division symbols. They don't really do much for me, so I'm going to go ahead and immediately build this quotient like so. So that expression written out with the division sign is the same thing as the actual fraction, t squared plus 4t minus 12 over t plus 6. Can we factor t squared plus 4t minus 12? Why am I writing that in there? That was not what I needed to do. I needed to set up a possible factoring. So I would love to factor that numerator, and I would love to see if t plus 6 is one of those factors. In general, you wouldn't necessarily be able to count on that, but for these problems, it is going to turn out that way. So you could either go ahead and put a t plus 6 into one of the parentheses up on top and hope for the best, or let's just do the factoring and hope that the t plus 6 ends up showing up. So again, I'm trying to put in little expressions in these two blanks that when multiplied will give us t squared plus 4t minus 12. Since the leading term is t squared, I probably need a t there and a t there. That's not the only way that can happen. For example, the leading term could have a 2t, and then the second term could have a 1/2 t. Multiply those, and then boom, there's your t squared. But let's not overcomplicate things. So the missing numbers, remember the game here, and that's all this is a number game. We're trying to find two numbers that will multiply to be negative 12, but will add together to be positive 4, because we will generate the multiplications of the inner terms and the outer terms. Each of those will be something times t, and they will add up to be that positive 4t. So two numbers that multiply to be negative 12. I'm just going to doodle that down here. Since my product needs to be a negative 12, one of these numbers is going to have to be negative. If they're both negative, that doesn't work because their product would be positive. If they're both positive, that's not going to work. Okay, so what two numbers can multiply together to be negative 12? Well, I got negative 4 and positive 3. I've got positive 4 and negative 3. I've got 6 and negative 2, and I've got negative 6 and positive 2. There would also be, 1 and negative 12, negative 12 and 1. So this list could get longer, but I'm going to stop with these to begin with. So all of these pairs could be the numbers that go into this spot and this spot, just to make the t squared and the minus 12 in the product. But we're looking for the pair of numbers that are going to add up to be plus 4t. And let's see, negative 4 plus 3, is that going to be positive 4? Nope. 4 and negative 3? Nope. 6 and negative 2? Yes. Okay, so if I come back up to the top, and just to really show this off, let's put an obnoxious color in there. How about t plus 6, t minus 2? That is my factoring attempt at that top quadratic. And if I multiply out, this numerator, I'll get t squared plus 6t minus 2t. There's the 4t, and then a trailing minus 12, and we are good. Okay, so with that factoring in place, then we can continue with the division, cancel, cancel, and the net result of the division is t minus 2. Okay, and then just remember what division does. Again, it's undoing multiplication. The original question is asking if t plus 6 is a factor of t squared plus 4t minus 12, what do we multiply it by to give the t squared plus 4t minus 12? And that answer is t minus 2. T plus 6 times t minus 2 is the t squared plus 4t minus 12. Okay, another example. Let's get rid of that red. That's kind of obnoxious. So again, on the worksheet, just to save space, it'll be presented like this, but really it's better to see the division with an actual fraction in place. Okay, so we would love to be able to factor the numerator. We would love for x minus 6 to be one of the factors of the numerator. Will it be? Well, let's see. Put an x there and an x there. Let's see, so two numbers that multiply to be positive 30, but that add to be negative 11. All right. So that means that the two factors we're looking for are both going to have to be negative, because when they multiply, we need to get a positive 30. But when we add them together to find those cross terms, we need to be at negative 11. So two positive numbers isn't going to work. So like if I took 6 and 5, that product would give me the plus 30. But when I added up 6x plus 5x from those cross terms, I would get positive 11x. Okay. How about negative 6 and negative 5? Again, that product is positive 30, and now the sum of those is going to be negative 11. So x minus 6 times x minus 5 is the factored version of x squared minus 11x plus 30. Double check it. X times x is x squared. X times negative 5 is negative 5x. This negative 6 times x is a negative 6x, and now we've collected negative 11x altogether, and then the product of the negative 6 and negative 5 at the tail end is your positive 30. So that factoring is good, and then cancel, cancel. The net result is x minus 5. Okay. Again, these problems are sort of pre-simplified for you because you will initially you will be asked to divide a larger polynomial by a smaller polynomial that is one of its factors, and the result will be nice and clean. Just like if you take 30 and divide it by 6, the result is a nice clean 5. Now, if you take 30 and divide it by 7, you can still do that, but you're going to have a remainder because 7 isn't a perfect factor of 30. And when you get into next week, that's going to be the next complication for polynomial division is what if I'm asked to divide x squared minus 11x plus 30 by x plus 4. X plus 4 isn't a factor of x squared minus 11x plus 30, but we can still divide it. It's just that there's going to be a remainder. So how do we end up finding that remainder? That's going to be the game for Monday. Let me show you this one last division problem here again that we're going to employ factoring, but it's got a little bit of an extra complication because that leading term on the left is a 2y squared, not just a y squared. So we would take this, and again, my preference is to write it out as a full quotient like so. Then we're going to hope that we can factor the numerator and then divide by y plus 1. And again, for these problems, we're going to hope that one of the factors of the numerator is the thing we're dividing by so that we can get that cancellation in the division, that nice clean cancellation. Okay, so with this setup, we're going to find what goes there and what goes there. that when we do this multiplication from this numerator, we end up with 2y squared plus 5y plus 3. Okay, so this is just trial and error. Since a single y is waiting here, and we want to multiply it by the mystery term here to produce a 2y squared, really the only option is a 2y in that spot. Okay, then we have one more spot to fill. There won't be any negatives here because all the joining up here is positive, so there's no negative numbers getting in the mix. So here is, again, we're hoping this is going to work. There is a 1 in place right here already, and we need this number times this mystery number to be what leads us to that positive 3. So that means this has to be 3. And now, to make sure this really is the correct factoring, we double check, run that numerator out and make sure that we are producing that 5y in the middle. Well, the 2y times the 2y from the first terms, remember FOIL is the 2y squared, so that's good news. Now the outer terms would be 2y plus 1, which is 2y. Then the inner terms would be 3 times y. So we got a 2y from the outside, a 3y from the inside. Altogether, there's our 5y. And then the last terms, the 3 times the 1, that gives our 3. Okay, so we have correctly factored that top, and now the division itself is easy. Right? Bang, bang, you're done. So the net result of that division is 2y plus 3. Okay, so from here, there are actually 2 worksheets in the folder in Google Classroom for division of polynomials. You are ready to do the first 4 problems on each of those worksheets. So there are 2 of them here, right? I'll show you them quickly. You are ready to do the top 4 on both. So there are altogether 8 practice problems for you to do that will flow exactly like these that I just looked at. The polynomials on the numerator will factor nicely, and one of the factors will end up being the thing you're dividing by. So once you're done factoring, all you have to do is cancel, cancel, and you're done. Next week, sorry, it's not going to be that quick and clean. But I believe Mr. Childress will be back on Monday to start taking you through more extensive long division of polynomials. And if that doesn't make you want to come back to school on a Monday, I don't know what will. And again, tomorrow, shorter periods, so I'll just have a review sheet in the folder for you that will kind of go back through several recent topics and make sure you're still firing on all cylinders with those.